Welcome to Cedar Falls, Iowa, and the University of Northern Iowa campus. Thank you for visiting the Metal Casting Center and Additive Manufacturing Center's website. I'm Jerry Field, the director of the centers, and I'll be your host today for your tour. The Additive Manufacturing Center was created over 6 years ago and houses one of the largest 3D sand printers in North America, along with polymer printers and ceramic printers for the investment casting industry. Our centers are open for scheduled visitors, but feel free to browse our site, tour the facilities, and review our capabilities, resources, and experience.
I'm Travis Frush, Project Manager for the University of Northern Iowa Additive Manufacturing Center. Now we're standing here today in our sand printing lab. Behind me here is the ExOne S-Max. This is where it all started for us back in October of 2013. At that point in time, this was the 6th installation in North America of this style of printer. Our primary objective in procuring this technology was to advance the adoption of the technology in metal casting. It was our intention to expand its application through additional materials, reducing the process and operating costs while capitalizing on the design freedoms of this technology. This technology, binder jetting, in this machine uses a binder agent that is selectively deposited to join sand particles together. It's a chemically bonded process. We coat the bed with an acid catalyzed sand, and then the print head comes across and deposits furfural alcohol selectively based on where in that layer the geometry is defined. And that furfural alcohol reacts with the acid coated sand to create the adhesion, and then it repeats that process. This build box in this machine, it's 1 meter in the y-axis, 1.8 meters in the x-axis, and as I said, 0.7 meters or 700 millimeters in the Z. So we can make relatively large monolithic cores and core assemblies, but that build box doesn't constrain us because of the design freedoms where you can eliminate the core assembly, you can eliminate all the tooling and the labor required to assemble the cores as well as the adhesives. And as long as you can clean the unbonded sand out, print complex core assemblies that reduce or eliminate stack-up tolerances. But really, this printer here prints with more variety of products and aggregates than any other printer of its type in the world.
Hi, my name is Craig Ertl, and I'm a research associate here at the UNI Additive Manufacturing Center. We're here in the physical properties testing lab in the UNI AMC sand printing lab. This lab is used to test the quality of sand molds and cores which are produced in each 3D sand printed build box. Each build box is printed with 15 X and Y transverse bars, which are used to assess the quality of those 3D printed sand cores and molds. This lab includes a dial indicator, which is used to assess the dimensional accuracy of the transverse bars in the X, Y, and Z dimensions. A digital balance, which is used to assess the density of those 3D printed transverse bars. We have a mold permeability tester, which is used to assess the permeability of the molds, which is also can be considered to be the amount of air that is allowed to permeate through the printed sand molds. We have an electronic universal sand strength machine, which also has 2 accessories attached with it. We have a core transverse strength accessory and a core tensile strength accessory. Those are used to test respectively for transverse and tensile strength of the 3D printed sand molds and cores. All of these tests are used in conjunction to assess the quality of the 3D printed sand molds and cores produced in each build box. The collected data from these tests is then used to ensure that the 3D printed sand molds and cores comply with the specifications set forth by our customers.
Hi, my name is Jai Wang. I'm working as a research associate at UNI AMC. Romer Absolute Arm is a best-in-class, highly accurate, portable, coordinated measuring machine. Romer Arm requires no homing procedures, no warm-up time, and minimum training to operate. With high-performance integrated laser scanner and a powerful 3D metrology software Polyworks, Roman R becomes an ideal tool for 3D scanning applications. Polyworks allows user to see the digitized data captured by the scanner in real time and conduct data cleaning, alignment, and merging in a very convenient manner. We use the processed data to generate color maps for geometric comparison and inspection, or save out as STL or point cloud data for 3D printing or reverse engineering. Romer Arm also provides 3 hard probes for touch probe measurement. We typically use them to check the critical dimensions of 3D printed products for quality control purposes. Hi, welcome to our design center at UNI AMC. The main task of this design center is to design geometries and prepare for 3D printing. For the 3D sand printing process, we design sand mold components such as coat, drag, core, insert, cheek, etc. using our standardized methodology, which integrates both sand casting and additive manufacturing design guidelines. For some projects, we also consider a hybrid option which uses 3D sand printed cores and inserts and sand milled coats and drag. Besides design for sand casting process, we also design gates and tree assembly for investment casting. For other processes that do not need much engineering design, we just need to check the geometry and make sure it is suitable for that specific process. Our center is also capable of doing reverse engineering using Geometric Design X or directly working with STL files.
The UNI Additive Manufacturing Center offers paid employment in support of 15 to 20 students throughout the year. The students are the individuals doing the work under the direct supervision of our staff. This provides experience-based learning in real-world industry applications that they can use after they leave the university and start in their own careers.
This is the Tinker Omega's robotic sand milling cell. This cell features a KUKA KR90 6-axis industrial robot. The application of this technology is for the production of coat drag casting mold packages through a subtractive manufacturing process. This technology uses conventionally available milling tools to remove the unnecessary sand grains from casting molds. The application of this technology is for the production of coat drags mold sections for casting mold packages. This technology can also be used in a hybrid process utilizing 3D sand printing as well as robotic sand milling to produce hybrid patternless casting mold packages. An additional application of this technology is the production of large monolithic molds in one single piece, as well as the utilization of large flat sizes that can be milled using the 90-degree table available in this cell. I'm here to introduce you our 3D printing lab. The first printer I want to talk about is this 3D platform Work Series 200. This is a industrial large-scale 3D
3D printer. It has a large build volume, 1 meter by 1 meter by half a meter, and 2 high-flow extruders, which allows this printer to print large parts with a relatively short printing time. Its open source system allows this printer to print highly customized parts with a variety of filament options. It enables a time-efficient and cost-effective solution to fabricating parts for a wide range of metacasting applications. In addition to all of the industrial applications, we also do applied research to see how this technology can help with more metacasting applications. The second printer I want to introduce is 3D Systems Project 2500 IC. Project 2500 IC is a material-jetting 3D printer that prints parts in 100% wax that fit directly in standard investment casting process. The printed wax patterns are with high detail, high surface finish, and high accuracy. Project 2500 IC is ideal for low volume production of small to mid-sized wax patterns with no tooling cost and significantly shorter lead time. For X800 is an industrial SLA printer that prints plastic parts with large size, high quality, high accuracy, and relatively low cost. With the quick cast build style, this printer can produce whole patterns directly used for investment casting. Quick cast patterns have an internal hexagonal support structure that adds strength to the pattern shell and facilitates collapse of the pattern towards inside during thermal expansion to help avoid shell cracking. The post-processing of quick cast SLA patterns involves 5 steps in general. First, we use centrifuge to help with the drainage of liquid resin inside the pattern. Then we remove the support structures and clean the surface of the pattern using IPA. The third step is to put the patterns in the UV oven to cure any liquid resin inside. The fourth step is to seal the vents and drains on the pattern surface and check the air pressure to make sure all patterns are watertight. The last step is to apply sanding or coating on the patterns to further improve the surface finish. Quick cast patterns offer a tool-free, fast, reliable, and accurate alternative to conventional investment casting patterns, largely reducing the cost and lead time. Wix 1000 is a high-quality bi-energetic AM system that can meet a wide range of industry demands. Wix 1000 has a build box of 1000 by 600 by 500 millimeter and is capable of printing ceramic, sand, and PMMA powder. Wix 1000 is ideal for fast and cost-effective production of mid to large-sized PMMA patterns. The first step is to clean the parts by removing the unbound powder on surface. The second step is to cure the parts inside an oven. The last step is to dip the patterns into molten wax and allow the wax to infiltrate into the part. Therefore, they can be directly used as expandable patterns for investment casting, just like conventional wax patterns.
I hope you enjoyed the look at the Additive Manufacturing Center. Please feel free to get a hold of us for a personalized tour and discussions how together we can move the industry forward.